Hello everyone, in this video let us learn how to control the speed of single phase AC motors. At the end of this video you will be able to
interpret the nameplate details of an AC series motor and determine full load current. Select a suitable variable resistor. Connect, run and measure the speed for different settings of the resistor. Let us collect the tools, equipment and machinery required to do this practical. Electrician toolkit, voltmeter, ammeter, tachometer, AC series motor, rotary switch, connecting cable as required, ICDP switch, wire-wound enamel insulated resistor. Let us discuss the AC series motor. A series motor is a type of electric motor where the field winding and the armature winding are connected in series, meaning the current flows through both windings in series. Working principle. When an AC voltage is applied to a series motor, the current flows through both the field winding and the armature winding. The current passing through the field winding creates a magnetic field, while the current passing through the armature winding generates a torque due to the interaction between the magnetic fields. As the current in both windings is proportional to the applied voltage, the magnetic field and torque change simultaneously, resulting in the motor's rotation. Traction systems. AC series motors are used in electric locomotives and trains where high starting torque is necessary to move heavy loads efficiently. These motors are also employed in elevators and cranes due to their ability to provide high starting torque, allowing for smooth and reliable vertical movement. Advantages. High starting torque. AC series motors provide high starting torque, making them ideal for heavy load applications. Simple design. The construction of AC series motors is relatively straightforward, leading to lower manufacturing costs. Compact size. These motors are compact, making them suitable for applications where space is limited. Speed control technique. Voltage control. By varying the applied voltage to the motor, you can achieve some speed control. Lowering the voltage reduces the magnetic field strength and thus the torque, leading to a decrease in speed. Connect, run and control speed at a AC single-phase motors. Read the nameplate details and record them in tabulation. To drop 80 volt at position 1 and to drop 40 volt at position 2. Calculate the required series resistors R1 and R2 and also determine their wattage. Each resistor should drop 40 volts, so the total voltage drop across R1 and R2 should be 80 volts. Since the field and armature windings are small, it will be negligible. To find the resistor value R1 and R2 to drop the voltage 80 volt. Resistance value can be found by using the formula R is equal to V divided by I. Voltage across the motor is equal to 160 volt. Voltage dropped across the resistor R1 and R2 is equal to 240 minus 160 is equal to 80 volt. R is equal to V divided by I is equal to 80 divided by 1.5 is equal to 52 ohms. To find the individual resistors value R1 and R2 is equal to R divided by 2 is equal to 26 ohms. Hence, the value of resistors R1 and R2 are 26 ohms respectively. Make the connections as per diagram and make necessary arrangements to load the motor through pony brake. To measure the current and voltage carried by the motor, connect a voltmeter V1 with a range of 300 volts in parallel to the field and armature windings and an ammeter with a 5 amp maximum in series with the windings. Connect the resistors R1 and R2 series to the motor windings with tapping positions at S2 like 1, 2 and 3 to control the voltage drop across the resistors, so that at position 3 no resistors are connected to the circuit and at position 2 only resistor R2 is connected to the circuit to make a 40 volt drop, and at position 1 both R1 and R2 are connected to the circuit to make an 80 volt drop. Now, connect the voltmeter V2 ranging from 100 volts in parallel to the resistors R1 and R2. Close the switch S1, set the switch S2 in position 1 and observe the starting of the motor. Measure the current, voltages V1 and V2 and the speed. Record the values in tabulation. Set the switch S2 in position 2 and measure the current, voltages V1 and V2 and the speed. Record the values in tabulation. Set the switch in position 3, measure the current, voltages V1 and V2 and the speed. Record the values in tabulation.
Conclusions. The relation between V1 and the speed of the motor is directly proportional. If voltage drop across V2 increases, the speed of the motor decreases. If voltage drop across V2 decreases, the speed of the motor will increase. True. The relation between V2 and fall in speed is inversely proportional. The value of resistance R1 and R2 by repeating V1 and V2 measurement at the loaded condition of the series motor is 52 ohms.
This concludes the exercise on how to control the speed of an AC series motor. Hope now you will be able to
interpret the nameplate details of an AC series motor and determine full load current. Select a suitable variable resistor. Connect, run and measure the speed for different settings of the resistor.
Thank you. See you in next exercise.